Welcome to this video lecture about ASP.NET Core with MVC. The agenda for this video lecture is getting started with ASP.NET Core MVC, adding a controller, adding a view, and finally adding a model. If you haven't downloaded Visual Studio 2022, you gotta install it, and during the installation you have to select ASP.NET and Web Development Package, and it should be selected when you install. If it isn't, go ahead and select it and install it. If you already have installed Visual Studio 2022, then you can add ASP.NET and Web Development by firstly pressing the Windows key, write Visual Studio Installer and press Enter. Or alternatively, you can click the Windows button down, usually down on the left, and write Visual Studio Installer and find it there. If you are requested, allow the installer to update. If update for Visual Studio 22 is available, an update button will be displayed. Choose to update before doing any modifications to your Visual Studio installation. Find your Visual Studio 22 installer and choose Modify button. If it's not already selected, choose ASP.NET and Web Development and then choose Modify. Otherwise, you can just close the dialog box. When you are done with your installation or just started your Visual Studio project, then you should select Create a New Project, which is displayed here in the illustration with the red borders. You can see where you can click. In the next dialog box that will appear, you have the option to create a new project. Within this dialog box, select ASP.NET Core Web App with parentheses Model View Controller and then press Next. In the dialog box, configure your new project, give it the name MVC Movie as project name and then press Next. In the subsequent dialog box, additional information. Select .NET 8 and verify that you do not have use top level statements checked. If these conditions are met, you can select Create. If everything went alright, you should see a screen similar to this in your Visual Studio 2020, and to the right you have your Solution Explorer, where you have a few different folders, being controllers, models, views, and you have an app settings.json file and a project.cs file, which is basically the main start for this web application. Besides this, you should have a play button at the middle top, where you can start the web application. In order to debug the application and basically start a web server for debugging the application, you can debug it by selecting the HTTPS button on the toolbar, which is marked with the red rectangle in this illustration. Visual Studio will run the app and open the default web browser. The address bar will display the local host and then a port number, and not something like example.com, because we don't really have a DNS at this moment. We only have our local host and our port number. The default value for your local machine is localhost, and when Visual Studio creates a web project, a random port is used for the web server. So in order to access your web server, you have to type HTTPS localhost with your port number, otherwise you won't reach it. When you have pressed the debug or the play button, so to say, the following image will show up or in your web browser, kind of. In other words, your web browser will pop up, and the actual web page and the web and everything here will display your pages and everything. And here you can see your your local host and the number you have in your URL, and you can see that we have this welcoming page where we have welcome, and we can learn about how to build ASP.NET Core web pages, and we have also a menu here at the left middle, and this basically has now started to run our web server and our web pages and everything. And in order to stop debugging our web page, we can either close the browser window, which just now popped up, or we could stop it by going back to Visual Studio and pressing the stop button. But if we close the browser window, we will also stop the application. When building web pages with ASP.NET MVC as our project type, we are applying the model view controller design pattern, and this is an architectural pattern that consists of mainly three components, being the model, the view, and the controller. And this pattern is helping us to create basically could be any type of app actually, but in web settings this can be useful, as it allows us to create more testable and easier applications to manage and update than more traditional monolithic apps where you have one large component that becomes very huge. Instead, here we have tried to divide our applications into at least three major bits, being the model, the view, and the controller. So by applying the model view controller pattern, we have models that are classes that represent the data of the app. The model classes use validation logic to enforce business rules for the data. Typically, model objects retrieve and store the state of the model in a database, while we have the views, and their main responsibility are to be components that displays the app's user interface, and generally this UI component displays model data as well. And controllers, they handle browser requests upon when browsing to the web page. They may retrieve model data and use models to kind of prepare for the view. And upon browser request, they may invoke view templates that are returned as a response from the controller upon a request to a web browser. In an model view controller application, the view only displays the information. It really doesn't do much else except holding the presentation logic. The controller, however, handles and responds to user input and interaction with the web server in this case. For example, the controller manages URL segments and query string values, forwarding these values for processing. And we can have actions within our controllers that can use these values to query the database. For example, if we have this URL here, HTTPS localhost with the port number 5001 with a /home/privacy. Here the home part in this URL specifies that we are targeting a home controller and with having a privacy action attached to it. In the second example here we have HTTPS localhost with a port number of 5001. We are targeting the movies controller with an action of edit by also passing a parameter with a value of 5. And in this example it is a request to edit the movie with the ID 5 using the movies controller and the edit action. And here we have two examples how we can perform these requests to the server with the URL. So let's get started with our web application and add a controller to our ASP.NET Core MVC app. So by doing so, we go to our Solution Explorer and right-click on our controllers and then select Add Controller. But in the next dialog box that appears to us for adding a new controller, we are presented with something called scaffolding tool, kinda. We will go and later on present and talk a little bit more about this scaffolding tool. But for now, we will just settle with just mentioning it as a dialog box for adding a new scaffolded item. And here we will choose an MVC controller which is empty, and then we click and select the Add button. In the subsequent dialog box that will appear, we will add new item dialog box, and here we will select the MVC controller empty type in hello world controller.cms and then check and choose Add. When done, we should see that we have now created a hello world controller. If we go to this hello world controller and open it up in our Visual Studio, we can replace the contents of that script with the following content. As we can see here in this illustration, here we have a outline for our hello world controller, which inherits from the controller data type. And we have two actions presented within this class of controller, which is called hello world controller. The first action we have is index, and this index method is returning a string, which basically is simply returning well, just text at the moment. This is, and it states this is my default action when called upon the index action. The second action we have available within our controller is the welcome action, and this one also right now only returns a simple string stating this is the welcome action method. So replace the contents in the controllers, hello world controllers, with the following code which are presented here in this diagram. When working with controllers, each public method in our controller can be invoked as an HTTP endpoint, basically meaning that it is a channel for communication for our web server and our web browsers. In the example below, or the previous example we looked at, both methods return a string. And note that the comments before each method kind of displays the HTTP endpoint types. Both of our methods in the hello world controller are of the type get. So basically they allow the controller to pass values to a browser. From the browser's perspective, it's about getting some kind of information or some kind of data, and in this case it is mainly just string values it might get. But there might be other different types of HTTP endpoints you can set up. The most common ones are get, post, put, and delete, where get is getting values from the web server, posting as a HTTP endpoint might be to send some data to the server. Usually it can become, for example, registering something in the database. Put as an HTTP endpoint could be to update something within the database through the controller. Like, for example, if you want to update your first name to something else, there might be a put request. And the final one, which is quite common, is the delete, where you actually want to delete an object within your web server and eventually in your database, for example. So an HTTP endpoint is an addressable URL in the web application, such as this example we see here, which is stating HTTPS localhost with the port number 5001 and a / hello world. This URL combines, or the HTTP endpoint combines, the protocols in use, which is HTTPS to begin, the network location of the web server, including the TCP port in our example, being localhost colon 5001, and the target URI, which is hello world in this case. When working with an application, especially here now with ASP.NET and MVC, the MVC, how to call it, the architectural structure activates the controllers and classes and action methods within them, depending on the incoming URL. The default URL routing logic used by MVC employs a format like this to determine which code could be activated. So in the example here below, we can see we have a / where we have a section within our URL that states the controller which we are targeting, followed by a / which states the action name we are targeting within the controller, and then we have a / which subsequently is followed by a parameter that can be passed to the controller. So when activating these controller action and parameters, for example, we are actually talking about the routing format for our web page. The routing format is set in the program.cs file, and we can see here in our illustration that we have a pattern here, and this is the default pattern to apply when incoming URL requests are incoming to the web server. So when browsing the app and not providing any URL segments, the default is the home controller in this example, as we can see in the illustration. It says pattern colon, and then you see the controller equal home. In situations where we do not provide any specific controller within our URL request, it will automatically go to the home controller. And likewise, if we do not specify any action within our URL, the default method will be the index method as specified in the template line above. And if, as you might have noticed also, we have also an ID parameter as well here, which could be passed as well. So the first part of the URL determines which controller class to run. So localhost 2005 as a port number / hello world matches to the hello world controller class. So they have to be identical in spelling. The second part of the URL segment determines the action method on the class. So localhost 5001 / hello world / index causes the index method in the hello world controller class to run. Note, however, that you only needed to browse the localhost 5001 as a port number / hello world, and the index method may be called by default. So it's actually possible to omit the action here for our controller. As the index is the default method that will be called upon a controller if a method name is not explicitly specified. And lastly, we have the third part of the URL segment, which in our pattern is called ID, which is for route data. So if you, for example, wanted to pass in a number or a letter or something else, it is possible here to provide our controller with some route data. So let's continue on the track of developing our web server and web application. So let's begin with modifying the code we have already to pass specific parameter informations from the URL to the controller. For example, in our hello world controller, we want to pass a name variable and how many number of times we will actually print this name. So in our URL, let's type in hello world / welcome question mark name equal Rick and number of times equal 4. But before doing this, let's update the welcome method to include two parameters as follows. And down below here we have the illustration of the changes we want to perform for our welcome action on our Hello World controller. So first of all, the welcome action returns a string still, and we want in our parameter list to take as input for this action a string name and an int number of times, which is set with a default value of 1 in case we do not receive any other value. And then within our action we simply do a return HTML encoder default and encode this string. The HTML encoder default encode method is a method that allows us to pass more securely values to our view. But simply here we are passing a string that says hello, the name of the variable which is the input in our action, and the number of times this variable number of times has as a value as an integer. So when we now run the app by debugging it and browse to our HTTPS localhost and our port number and hello world and / welcome question mark name equal Rick and number times equal 4, we receive this output, which is displayed in our illustration below. As we can see, the URL has picked up our variables Rick, the variable name, which has the value Rick, and our variable number of times, which has the value of 4, and it displays this in our view for our in our browser. Here you can try different values for name and number of times in the URL and see how it actually behaves. The MVC model binding system automatically maps the name parameters from the query string to parameters in the method, in other words in our action method here in our controller. So in the previous illustration and in the web application, the URL segment parameter is actually not used. We are simply relying on the in the query syntax there, or query string. The parameters name and number of times are sent in the query string instead. The question mark is in the above URL, or in the slides previous to this one, is actually a delimiter, and the query string follows it. The ampersand character, the end, separates field value pairs. So we have variable and values. So now let's replace the welcome method with the following code instead. Let's put public string welcome, and then let's have a string name and an int id equal 1 instead in our parameter list for our action here, or action method. We do the same thing. We return an HTML encoder default which encodes a string here, and we simply say hello to the variable name, and then we have the ID, which is the input from in our method. Run the app and enter the following URL, HTTPS localhost and the port number you have, and then followed by / hello world / welcome with a slash of 3, and then a question mark name equal Rick. And let's see what actually happens here now. So here now in the previous URL example which we had, and when we typed it in, the third URL segment matched the route data parameter ID, which is contained within the map controller route method which we previously looked at. And what happens is that the welcome method contains a parameter ID that matches with the URL template in the map controller route method. The subsequent question mark starts the query string. So here we have the possibility of combining both of these techniques actually. We can both use the ID value here in our map controller route, and we can use our query string initializer with the question mark and have a key these field value pairs. So the third URL segment matched the route parameter ID, as we can see here in the pattern here above. The welcome method contains a parameter ID that matched the URL template in the map controller route method. The subsequent question mark in ID question indicates that the ID parameter is actually optional here within the pattern. So now that we've gotten the hang of route data and the route format, let's start adding a view to our ASP.NET Core MVC application. We will begin by updating our Hello World controller, as we can see here in the illustration to the left. Here we can start by defining a new public string index that does not anymore simply return a string as it does now in the left illustration. Instead, we want to do as we do in the right illustration here, and we have a public action result index action method within our controller that returns a view instead. And let's see how we can continue to set this up on the next slide. So let's add a view. Right-click on the Views folder and then select Add New Folder and then name the folder Hello World. Now let's right-click on the Views Hello World folder and then select Add New Item. A dialog box will then appear, looking like this. In this dialog box, select Erase View Empty and then have the name as index.cs.html, and then eventually you can click Add as well. So let's repeat that. In the Add New Item dialog box, select View All Templates, and then in the Add New Item MVC Mover dialog box, in the search box in the top right corner, type View, select Eraser View Empty, keep the value in the name box as index.cs.html, and then select Add. You have now created a view. Open up the view and replace the content in the file, which you should find at Views Hello World and then index.cs.html. The Eraser view, replace the Eraser view with the following code. We begin by having a view data dictionary with a key title, and to this key we attach the value index. This view data and the title will display the index name of the page on top of the tab in the web browser. And then we have an h2, which is a header calling index just on the page, and then we have a paragraph hello from our view template. If we now navigate to the HTTPS //localhost and our port number /hello world, a view template file name was not specified, as we can see in the URL above. However, we reached our index page. And this is because MVC used the default view file by default. When the view file name is not specified, the default view is returned. The default view has the same name as the action method, which is index in this example. The view template views hello world /index cs.html is then used. Perhaps you have noticed that when traversing the web page, and when you select the different menu links like MVC Movie, Home, and Privacy, you note that each page displays the same menu layout, among other things. This is because we have a menu layout that is implemented in the file views shared _layout.cs.html. This file is actually a shared file among all of our views. So if we open up the views shared _layout.cs.html file, we can study it a bit. And we can find that the line with the @renderBody method, renderBody is a placeholder where all view-specific pages you create will be displayed actually, enclosed within the layout page. So the layout page will always surround whatever view you actually create here. For example, if you select the privacy link, the views home privacy cs.html will be rendered inside the renderBody method. So let's continue here and modify the views and our layout pages in our ASP.NET Core MVC app. So if we go into our layout page and we change the title, footer, and the menu link within our HTML file, you can see that you can make 3 changes. Where you can change that whenever the title of the page is displayed, it will also display the Dash Movie app in our main menu. Let's add also, we have a movie app, which will always be displayed on whatever page we go to. And at our footer in our page, let's add also a movie app here that will always be displayed. So when we do these changes in our layout file, all of these changes will be reflected on all pages that uses this layout, shared layout, so to say. So now that we have a view and a controller, let's start transferring data from the controller to the view. The controller actions are triggered in response to an incoming URL request. A controller class is where the code is written to handle the incoming browser request. The controller can retrieve data from a data source and determine what type of response to send back to the browser. And view templates can be used from a controller to generate and format an HTML response to the browser. So controllers are responsible for providing the data required for a view template to render as a response. View templates should, however, not perform business logic, interact directly with a database, or a view template should only work with the data provided by the controller. Maintaining this separations of concern rule helps to keep the rule clean, testable, and maintainable. Currently, the welcome method in the Hello World controller class takes a name and an ID parameter and then directly outputs the values to the browser. Instead of just doing this, let's start letting the controller render the response as a string, change the controller to use a view template instead. The view template generates a dynamic response, which means appropriate data must be sent from the controller to the view to generate the response. To do this, by letting the controller place the dynamic data, also known as the parameters, that the view template needs into a view data dictionary. The view template can then access this dynamic data instead. So let's update our welcome action method again. Here we can see in the yellow marked regions here in our illustration, we have the public iAction result welcome method, which has a string name as a parameter in and an int number of times with a set of with a default value of 1. These variables, which are passed to the controller, are actually then passed to our view data dictionary through inside the controller. Here we can now see that the message key in our view data dictionary is set with the hello space and the name we provide the controller. And our view data dictionary has also a key that is called num times, which is set to the value of the in passing variable num times. Then we return a view by calling the view method, which is returning an iAction result in the end. So moving on to our new view, we can see that we have, to begin with, a part which says that we have our view data dictionary with the key title being populated with the value of welcome. This title key will be responsible for displaying the welcome message at the top of the tab in our browser. Then we have a h2 welcome element with the word is welcome inside of it. And then we have a list that uses a C# code inside of the HTML. You can do this by having a @ sign and then typing C# code straight into the HTML. And here we can see that our for loop is actually relying on the view data and specifically the num times key here, which has been set previously by our controller to be of the value of the passing URL segment. And here we can see that our code here runs the for loop as many times as the num times variable has its value. And it will show this view data dictionary key message and retrieve the string value from this dictionary and print it in our view. So now that we've started working with the view data dictionary, the view data dictionary is a dynamic object, which means any type can be used within it. The view data object has no defined properties until something is added to it. The MVC model binding system automatically maps the name parameter's name and num times from the query string in the controller to the parameters in the method. So let's test this out. Browse or navigate to the following URL: https://localhost and our port number, and then /hello world to target our controller, and then /welcome name equal Rick and number of times equal 4. The data is then taken from the URL and sent to the controller using the MVC model binder. The controller packages the data into our data view dictionary and sends that object to the view when the controller is done with it. The view then renders the data as HTML to the browser, and in the illustration to the right we can see the output of this happening here. So in the URL we can see that we have our HTTPS localhost and we have the port number 1, 2, 3, and 4 and /hello world, which is our controller. And the action method is welcome and having the query string values behind it indicated by the question mark. And the value pairs are name equal Ricky separated by an ampersand, number times equal 4. And we can see here that in our page we have now dynamically written hello Rick 4 times actually. So now that we have transferred some data from the controller to the view by using the view dictionary in the previous example. Instead, however, a view model can be more useful and a more efficient way to send data from a controller to a view. The use of view models to send data is preferred over the view data dictionary approach that we just did. So before we go into view models and how to pass models to our view, let's begin by simply creating a model to our ASP.NET Core MVC application. And basically a model are classes that are added to handle movies in our database in this application. So let's begin with a movie model. These classes constitute the model in the MVC application. And these model classes are used with Entity Framework Core to work with a database. If Core is an object relational mapping framework, that simplifies the data access code you have to write in order to communicate between the data access code and the database. The model classes created are called POCO classes. For example, our movie class here is a POCO class. It stands for Plain Old CLR Object. POCO classes have no dependency on Entity Framework Core, but they simply define the properties for the data to be stored in the database. So let's add a data model class to our application. Add the file into models/movies.cs with the following code, as presented below. Here we have now created a public class movie which has a few properties attached to it. First of all, it has a public int ID property with a get and set functionality. In Entity Framework Core, we know that whenever you type a property with the name ID, Entity Framework will see that as a way of specifying that this type of model we'll use the ID parameter property as a primary key in the database. Then we have a public string, which is nullable, which is called title, which is a property as well. Then we have a release date property, which uses data annotations in order to specify more specifically what kind of data type it is for the database. And this type, it is a data type of date. And then we have some other properties into our model here as well for our movie objects. We have a public string genre, we have some public decimal price as well for our movie objects. So the data models we will be using here are simply a way to communicate a little bit with Entity Framework how we want our database to actually behave. And it provides structures to our objects. So before we start using our model and start instantiating movies and objects like this, let's start doing some automatic generation of views. We can use the scaffolding tool to create pages for creating, reading, updating, and deleting our movie models, or eventually our objects. And using the scaffolding tool can be a very efficient way to streamline some of the more generic functionality within our web page. So let's have a look at how we can use this tool to increase our efficiency. In Solution Explorer, right-click on the controllers folder and select Add New Scaffolded Item, as we can see in the illustration to the right. In the Add New Scaffolding Item dialog, in the left pane, select Installed Common MVC, choose MVC controller with views using Entity Framework, and then select Add. In the illustration below, you can see the red rectangle indicating the option. Now let's complete the Add MVC controller with views using Entity Framework dialog box, which should have appeared now. In the model class drop-down menu, select Movie, which more specifically would show MVC movie.models. In the data context class row, select the plus sign, the button in other words. In the add data context dialog that appears, the class name mvcmovie.data.mvcmovieContext is generated. Now select add. In the database provider drop-down menu, select SQL Server. Keep the default values for view and controller names, and then finally select Add. So let's repeat that a little bit. In this dialog box, Add MVC control with views using Entity Framework. At the top of it, the model class, select Movie, like this, shown in the red rectangle here in the illustration. Then in the DB context class, you should have pressed the plus sign and created and generated a MVC movie context. Then for the database provider, you should have selected SQL Server. And when you're done with that, you can press the Add button below. So now that we have asked the scaffolding tool to automatically generate our views, it has actually done quite a lot of things. First of all, the scaffolding tool has added the following packages to our web project, and that being Microsoft Entity Framework Core.sql server. It also installed Microsoft Entity Framework Core.tools and Microsoft Visual Studio Web Code Generation.design. Moreover, it has, by the scaffolding tool, created the following things as well in our project. It has created a movie controller, and under controllers /movies controller.cs, and a race and several racer views, I should say, which constitutes our create, delete, details, edit, and index pages for all in relation to our movies controller. It has also created a database context class, which you can find on the data/MVC movie context.cs. And it has also kind of connected all of these views with actions in our controller together with the entity framework MVC movie context as well. It has also, by using the scaffolding tool, updated the following things. It has inserted necessary package references in the project file MVC movie. It has registered database context in the program file.cs for our usage. It has also added a connection string to our database in the file appsettings.json file. And also, the automatic creation of these files and file updates are called scaffolding. So basically, it has done a lot of things for us now. So the scaffolding pages, which we've now created, cannot be used yet, unfortunately, because the database does not actually exist yet. We have, however, generated our pages, the controller, and the database context. However, if you run the app and select the movie app link somewhere where it's supposed to go and fetch some data from the database, it will result in an error message saying cannot open database or no such table movie. And this is because we have not yet migrated our first initial database migration with Entity Framework. So we need to do this to actually get it to working. But we can at least start and build the app to verify that it actually works without any errors. But in the next step, let's look at how we can perform our first initial database migration with Entity Framework. So let's use the Entity Framework Core migration feature to create the database. Migrations are a set of tools that can create and update a database to match the database model, or the data model. From the Tools menu, select NuGet Package Manager and then select Package Manager Console. In the Package Manager Console, which we usually shorten as PMC, enter the following commands to get it running. In this script, we will write add-migration initial create, and then on the second line we write update-database in order to create our first initial database migration with Entity Framework. So now that we've done this, let's review the generated database context class and registration. So in EF Core, data access is performed using a model. This model, a model that consists of entity classes and a context object representing a session with the database. The context object allows querying and saving data. The database context is derived from Microsoft Entity Framework Core.dbContext and specifies the entities to include in the data model. So the scaffolding tool has created a database context class, which you can find under data/MVC movie context.cs. And below here we can see this actual class. It derives from the parent class dbContext in order to create our own dbContext class, which we call MVC movie context. It has a constructor which takes in a dbContext options with the generic type setting of MVC movie context and options, and passes these options back to the dbContext father class through the constructor and through the base method. Below this, the constructor, you can find we have a property called dbSet. This dbSet takes a model and looks at the model's structure in order to generate this dbSet as a table in our database. So the code above creates a dbSet movie property that represents movies in the database. ASP.NET Core is built with dependency injection. Services such as the database context are registered with dependency injection in program.cs. These services are provided to components that require them via constructor parameters. In the file controllers movies controller.cs, the constructor uses dependency injection to inject the MVC movie context database context into the controller. The database context is used in each of the CRUD methods in the controller. So in other words, dependency injection allows our components to request other components. And in the example of this, in our movies controller, we are requesting the database context for use. So regarding the dependency injection, the scaffolding tool generated the following highlighted code in our program.cs file. As we can see here in the yellow highlighted area, we have, through our builder, where we can attach different services and later on request them, we have attached our DB context of the form MVC movie context and passed in our options variables, which use our SQL server, and then our builder and the configuration for the connection string to use. This is a way to allow our program to attach many different services to later on be used by other components through dependency injection. If we review the generated connection string to the database, we can see that the scaffolding tool has added a connection string to the app setting JSON file. In the yellow area, we can see that we now have a field called connection strings, which has an object that is having a field called MVC movie context with the value of our connection string, which is the data source equal MVC movie context and all of these numbers and letters with ending on a .tb. And this is where the DB context goes to fetch our connection string in order to connect to our database. When we now did our first migration with Entity Framework Core, we received our first initial create class in the background. We can see here that we have an initial create class that is inheriting the properties of our migration class, which is a class from our Entity Framework. These migration classes, which are generated automatically through our migrations, is a way of keeping track of the progress the database model is having in relation to our models we are attaching to it. It allows us to create, for example, our initial create app method creates the movie table and configures ID as the primary key. And this is a way of keeping track of the changes that is occurring in the database over time and in this model. And if you ever want to progress down the hierarchy of migrations, you can always use the down method to revert the schema changes made by the up migration. So this is a way of keeping track of how Entity Framework has built your database model. And the idea here is that as your application progresses and develops, so will most likely your models as well, and your database model might have to follow along as well then. If we now take a little look at our dependency injection in the controller, if we open the file under controllers folder and then movies controller.cs and review the constructor, we can see that our constructor is taking in a parameter called MVC movie context named context here. And this is actually the dependency injection here. So in the movies controller, in the constructor of this class, we are able to request now the context in our ASP.NET Core MVC project here. And now we are able to use this connection to our database throughout all of our action methods in this controller. So let's review this once more. The constructor uses dependency injection to inject the database context, in our case the MVC movie context, into the controller. The database context is used in each of the CRUD methods in the controller, as you can see if you study it. Here you can test the creation of the page, enter and submit data through all of these methods, and by visiting the different views when you run the application. You can test the editing, the details, and the deletion pages as well to see how it actually works with the DB context here. Preferably, I would recommend you if you could put a breakpoint inside the application somewhere and follow along as the code progresses, and you can actually see how it all works. So, previously we looked at how a controller can send data or objects to a view using the view data dictionary. The view data dictionary is a dynamic object that provides a convenient way to send information to a view. Our MVC project type, however, provides the ability to send strongly typed model objects to a view. This strongly typed model approach enables compile time checking of code, actually. The scaffolder mechanism sends a strongly typed model in the movies controller class and views. And let's have a look at how this actually works. So if we review the generated details method in the file controls movies controller, we can see that we have a details action method here that has public async task I action result, and it takes in a nullable type of int ID here. In case we have a ID which is actually null, there has not been a ID value passed to this controller through a request, then we can return a not found view. If we however have a ID passed to this controller, we can go through the context and through the collection of movie. We can hopefully find our movie we are looking for by the ID value. However, if the case would be that we cannot find a movie and the movie variable would be null, in those cases we will return not found view in this case. However, if we do find a view, we will return a view with the object movie in mind here, as we can see. And this is actually passing the movie object and its model, which is underlying it. Typically, the ID parameter is sent as a route data. For example, like https://localhost and the port number /movies/details/1. Here it sets the controller to the movies controller, the first URL segment in this structure. Action is set to details and in the second URL segment, and ID is set to 1 in the last URL segment. ID can also be sent in as a query string, as in the following example we see here below, where we have the movies controller /details ID = 1. So let's review the details view. At the top of this view, we have the @model statement, and this specifies the type of object that the view expects to receive. When the movie controller was created, the following @model statement was included. So the controller passed the movie variable, remember, which was of this type movie. So we have to pass such an object to this view now. And we can see here also in the view that we have still using the view data dictionary and setting the title key with the values details. And we still have, we are having a header that says head details here on the page. And then we have a div which has some more elements to it. And in our HTML code here, we can see that we are using this HTML helper tags to display information about our model. So we can, by using our lambda expressions here, say where model goes model.title to actually reach the specific values of this model we are looking at. In our case, the model is the movie object that was sent to the view from the controller. So it would only make sense that the model here is actually, as we state at the top of this document, that the model is of the class movie, and therefore we can reach all of these properties of that object. So let's repeat that a little bit again. This @model expression allows access to the movie that the controller sent to the view. The model object is strongly typed. For example, in the details CS_HTML view, the code passes each field of the movie to the display name for and display for HTML helpers using the strongly typed model object. Similarly, the create and edit and methods and views also send a movie model object in a similar fashion. If we have a look at the index view, the index view CMS editor view and the index method in the movies controller, we can note that how the code creates a list object when calling the view method, as indicated here below in the illustration. The code sends this movies list from the index action to the view in a similar fashion as we did with the previous example. So let's have a look at the index view. At the top of this document, the @model expression allows access to the list of movies that the controller sent to the view using a strongly typed model object. Remember, in the controller it passed a list of movies. For example, in the index.cs HTML view, the code loops through the movies for each loop over the strongly typed model object. Since the model object in this view is strongly typed as an enumerable movie object, each object in the loop is typed as a movie. And we can see this in the highlighted areas in this view. Here we have for each, where we go through each item in the model, and here we can see that we can access each property of the specific movie objects within that collection. This actually indicates the end of our video lecture here. The material that has been the foundation for this video lecture is from the Microsoft company and their tutorial on getting started with ASP.NET Core MVC. In this video lecture, of course, you cannot click this link here, but in the material on Canvas, you can actually click this link and get to the material. There are more extensive materials to cover in this tutorial from Microsoft, and it also has a little bit more specifics you can actually delve into if you like, which I would recommend you to do. So in this video lecture, we have had a look at getting started with ASP.NET Core MVC. We have learned how to create a controller. We have looked how we can add a view into our project, and we also looked at how we can also include a model into our project. Moreover, we have looked at entity framework, we have looked at dependency injections, we have talked about strongly typed views, we have talked about the view data dictionary, for example. So there are many things we've gone through here, and now you should have a solid foundation to start your own ASP.NET Core MVC project.